Hi everyone, I'm Lee-Jae-sung. Today I'm going to talk about etching process, which is an essential and significant process in the semiconductor manufacturing process. Why is etching process important? Since few years ago, Samsung and TSMC have begun production of 3 nanometer chips. By the way, how small is 3 nanometers? A human hair is approximately 100,000 nanometers wide. As the size of the pattern of chips is becoming smaller, the etching process is becoming more significant. Then, what is etching? Etching refers to the process of selectively removing unwanted materials from a silicon wafer using liquid reactant or gases. Etching process can be broadly categorized into two types: wet etching and dry etching. The classification is based on whether a chemical solution or plasma is employed in the process. The most basic etching process is wet etching, also known as chemical etching. Wet etching is accomplished by immersing the wafer in a chemical solution container. As a result, the chemical reaction occurs between the solution and the oxide film, leading to etching. However, dry etching, also known as plasma etching, involves bombarding the substrate with ions in order to etch. It etches physically or chemically through the methods such as sputtering or plasma. In the process of sputtering, argon gas is ionized into plasma, and the accelerated argon ions collide with oxide film, physically removing it. Imagine there are argon hammers and stones called an oxide film, and you are breaking oxide film with an argon hammer. Now let's see the difference between wet etching and dry etching. The first difference is the direction of reaction during etching. When it comes to wet etching, since the method involves chemical reaction, wet etchants are usually isotropic, which means it etches in all directions. However, dry etching is anisotropic, which means it etches in one direction because sputtering etches physically. The second difference is undercut issue. Undercut refers to excessive etching, which can destroy the tiny patterns. The isotropic characteristics of the wet etching can make undercut reason. When making patterns larger than micrometers, the undercut issue is not a significant issue, but when making nanoscale pattern, the undercut reason can cause destruction of patterns, so wet etching is not suitable for making precise patterns on nanoscale size. In contrast to wet etching, dry etching is mostly used to make the fine and precise patterns due to its anisotropic characteristics. The third difference is the selectivity. The selectivity describes the relative etch rates between a mask and the etch target. Wet etching exhibits high selectivity because the chemical reactant reacts against a specific substance. On the other hand, the selectivity of dry etching is lower than that of wet etching because during the sputtering process, the argon ions can also hit the mask layer in addition to the film. The fourth difference is the speed of the throughput. Wet etching has high throughput. It allows for etching multiple wafers at the same time, immersing them in the chemical solution, whereas with dry etching, it's not possible to etch multiple wafers at the same time because it allows for etching a single wafer using plasma etching equipment. The fifth difference is the cost. Dry etching requires specialized vacuum equipment for plasma, while wet etching doesn't. In addition, wet etching can etch multiple wafers simultaneously. Therefore, wet etching is more cost effective. However, here's the thing. Even though the cost of dry etching is higher than that of wet etching, many companies use dry etching for semiconductor chip production because it allows for making nanoscale dimension of patterns. These are all information about difference of wet etching and dry etching in the semiconductor process. I hope this can help you to understand more about the semiconductor process. Thank you for listening to my speech.